What I want to do is get down this little bar. Because this is basically what you can demonstrate, like if you want to go around, that you can take normal, ordinary motors, right? We'll show you this. You were asking questions about this light. You can take normal, ordinary tape drive motors. And you were asking about the radiant energy, so you can demonstrate the radiant energy.
Can you start it up again, John?
That's the radiant energy, and then when you suck off the radiant energy, right, to the next battery, right, what?
Goes off.
And accelerate. That's a fast one.
Yeah, it's drawing.
Well, it's putting. So here. We'll just put this meter on the output battery. Now let's turn it off. So you can sit there and not consume anything. And you can see this battery doesn't want to sit up there at that level.
Going down. 13,
Oh yeah,
4,
it's going to go to standing. That's what all lead acid batteries do, is they go to standing, and this one you could sort of take with you. And you could always demonstrate it.
Which is 12. Standing's 12.
Yeah, this is 12 volt, and actually what I'll do is I'll hook it all up when you're ready to do what you're going to do. We'll put the right cables on it and everything, so and you'll buy your 2 batteries or whatever you're going to do.
Right.
But here, now, so we'll start this again, and we don't want to hurt this meter, so we're going to take this off here. And you can see the radiant energy there. And we'll show you that the battery's still right there.
13
Yeah, that's, now watch, we're going to give the radiant energy to the battery.
And that started to go up when you hooked up.
Well, when I take the output from this,
You put it on the battery.
yeah, well that's what you want to do. You want to charge the second battery. You want to be able to use this power.
So basically, this battery runs this motor.
Triggers it.
Triggers it.
Right.
And the circuitry will pulse, trigger the radiant energy.
And it goes there.
That goes in there.
Well, yeah, we look at.
So the net result.
So let's turn it off and watch it go down. And you can see there's no battery feed here at all. There's no generation.
Oh wow. That's just the standing voltage of that battery, which is not decaying.
Is this decaying? No, this is keeping going, right?
No, that's
No,
okay.
it's not.
That's decaying.
Yeah.
But there's no generation action.
Right.
It's not a generator.
Oh, I see.
So you're
as
at
soon as
stop.
you stop this, yeah. I see what you're
This
saying.
is a triggering mechanism.
Right.
Right.
Made out of a tape drive motor from a Sony camera. That's what that's made out of. Okay. So you can see that there's no generator action because it's coasting to a stop.
Right. Right.
That's kind of weird, isn't it, Tony? Because if I take and I short
Yeah.
this out, it's going to whoop,
Yeah.
stop.
Yeah. Yeah.
So it's totally got all those fields canceled out.
Is that a modified motor or a stock motor?
No, it's stock.
You haven't built it, you just took the motor and
Just took the motor and put that took off the shield and everything and said, okay, we'll put our circuit here and it'll do it.
Oh, interesting.
So you can just take an off-the-shelf motor and do that.
That is fascinating.
That's what that shows. So now you can see nothing's going to change here when I hook it up. So nothing's leaking from that battery to this battery. See? It's not doing that at all.
So it is the motor that makes the difference.
Well, it's the triggering
It's the
mechanism.
triggering mechanism.
Now watch. Let's look at the rating again. That's indicated by these two neon lights. The high voltage thing. Put your finger there. Grab onto these two. And now watch. And we'll put this on there. You can see that battery's there. Right? Watch. Climb it up.
But this is not one where when you take the load off, it blows up.
No. No, because it's got the protection, you know, and it's low enough voltage. Now, you get that to 24 volts and the wheel will come flying off then.
So the protection is your little lamp.
Yeah.
Okay. If you did have that, you'd have a set of 2 volts.
Right.
Is it?
That is a standard off the shelf. It's what they throw out in the garbage. You know, now we got a battery, probably not a very good battery over here. Something that's even bigger than this battery, right? And you can see, we'll just hook it to this battery. See this battery,
All this trigger circuit will put out is radiant energy.
Yeah.
It won't put out anything else.
no, it's not putting out anything else but the
Just
radiant.
radiant energy.
You see it's bringing this battery down because it's charging it.
Right.
That's what we got anything in it.
So the trick, quote unquote, is what your circuit does with the output of the coil.
Yeah. Let's see if there's anything in there. Nothing in this battery. See, but it's trying to adjust to this load. Hear it?
Yeah.
So if we take this, see, there is. So you can see that this is a dead battery, and it's going to put the charge in there. Here. Now watch. Pretty dead, probably been sitting around for a couple of years. So he's going to put it in there.
Take a look at it.
Of course, this one's a good one. Pretty sure this is a good one. Yep. But it's just the idea, see? To get a good battery on there. And then you can just watch it go up.
When you had that bigger light bulb plugged in and you took it away and its light went off and you put it down close, the light came on again. Is that
Yeah, this post here, see?
okay?
It's just hanging there. There's something in it, but these have been laying around dead. I think these were left over from the shop way down there. But to even get that much in it,
Yeah, okay.
you know,
No, I thought the other end was off, that's why. Because you've done something like that last time we were here.
yeah, I mean, you're talking about a totally dead battery there.
Right.
That was a neon bulb last
Yeah.
time. This is what they gave us.
Yeah, if you would like that light to have anything in this battery.
Yeah.
You know, and this will want to put it there. See?
See some bubbling.
Yeah. Yeah, cold boil. So take it back over here. This one's got 15 volts in it. And just see the radiant? Bring it up. It's gonna take it a while because it's gotta be unsolid.
Okay, we're looking at a brushless motor, and one of my visits to this shop here, John had made this brushless motor here, so I replicated this exactly. I don't have mine here, but we have a dual SSG circuit here,
SSG is what?
simplified schoolgirl motor. And so what John did is he took a conventional motor, brushless motor, out of the tape motor, and took out the circuitry, which is on top here, and just used the coils and the magnet as a motor, and was able to charge batteries while he was powering the motor.
So this motor is out of a what?
Tape motor?
What do you mean by a tape motor?
It's out of a tape editing machine
Okay.
from NBC. It's a capstan motor.
Okay.
So this is a little bit more powerful one than these fans. So I took this home and I played around with it, or I made my own at home. Played around with it for about 6 months or so, and then I got the idea. Well, I'll just try one of these, conventional fans because it's the same kind of motor. So I started off with a really small one that you'd find on a computer, maybe 2.5 inches, and that was, interesting. I got some interesting results from that. So this was a little bit bigger one, about 4.5 inches. It's just a Radio Shack, almost 4-watt fan here. I just built this one the other day. So again, you take it apart. You take out the circuit, which is in the back here, and then I just removed that, and I used the wires that were inside there, just like this one. What I was, interested in doing is seeing the same thing happen with this model that John had made in this fan. So I did that, and I thought it was a pretty good motor to use to compare, to find the mechanical efficiency, because the RPM is rated in the CFMs. So if I can get the RPM on this brushless motor to what it was originally, then I can see how much work is really being done. So we'll just look at this one for a moment here. Now I've got this, it's overrated for these batteries, but you'll be able to see it. This battery is charging, this battery is powering it.
Which battery is powering it?
This battery, well, this one is powering it, this one's charging.
So they correspond to the two batteries in the same order?
Correspond.
Okay.
So you've got about 100, about 90 CFMs coming out of this fan here. What was interesting with this particular setup is we were running this all day on a different set of batteries all the last couple of days, and the primary battery just sat there. It was quite unusual for this setup, but you never know what to expect from some of these systems. If you want to look here, this particular setup,
It just went up, right?
yeah, this one's kind of fluctuating. It's probably at about 100 CFMs there. So this was the same circuit that John was just using. We're
Using in
the
window motor?
Window motor. Now what I've added here is just a very, very basic capacitor pulsar, which I'm just using a capacitor and an SCR and a little diode. And that's converting the negative energy output of the circuit into more of a positive energy. And this gives me the capability of rotating these batteries around. As we just went over, if you're going to mix the energies, it gets difficult. It's difficult to run the SSG off of negatively charged batteries, and that's a whole thing to explain. But so this is just a cat pulsar, a basic cat pulsar. In fact,
Cat pulsar?
capacitor pulsar is what we call it.
Okay.
Cat pulsar. And when I actually added this to this particular fan, the amp draw went.
The what?
The ampere draw from the primary battery went from 550 milliamps at 12 volts to 475 milliamps, just by adding that little capacitor and SCR. Now, what I have here is a larger setup. I don't know, is that too close? Which I made a little case for. This one's in the process of being constructed. The idea, this is a 6-inch fan, another brushless motor. Exactly the same kind of motor inside. There's 4 little coils, and you can see on this one the coils on the other side. This is just a larger one. This is a little kit that I put together for people to test out. So
And what are they testing out?
well, they're just being able to see that, with a fan, now they can charge a battery instead of just wasting that energy. And the idea with these setups is you can rotate the batteries back and forth and keep the fan going so long as you rotate the batteries back and forth.
And so long as you're using a positive energy.
Positive energy
If
with
you
the
use the
capacitor.
positive energy.
Yeah. So I've got on this one, some switches, double pole, double throw switches to rotate the batteries. You've got 4 wires here to change them, one from being the primary charging or powering battery to the other one being the charging battery, then flip them back and forth. And depending on the battery size that you're using, these are very small batteries, so they're not going to last. The primary battery is going to drain pretty fast, so you'd have to rotate it back, every so many hours. But I've got the same circuit, a little bit bigger on a ceiling fan that I ran for several months last summer, where I just, rotated it back and forth between the 2 batteries. So the energy from one battery will go down, and then the other one will be charging up. And then, when it goes down low enough, you just flip the switch, and it'll just keep on going. Now, one of the things that, I don't know if John's mentioned today, but you want to give the battery some rest. So in this system, it would be better to actually stop the system for a little bit, give it some rest, and then flip it and rotate it, and then, or maybe have another battery bank. So here's another thing that's very interesting. I'm going to put a little bit of, load on this. And of course, if you look at the voltmeters, you find that the primary battery that's powering the system will draw less.
The primary battery being that one, okay. Right, you load it up and it takes less power.
Now, on a conventional motor, it would be the opposite, where it would take more energy, it being under a more greater load. So you can see it going down, but yet, and look at the charging battery, which is right here, and it will actually charge a little bit better. Now, there is a sort of a mechanical sweet spot that I found with this particular brushless motor conversion, and that is almost to the point of stopping it. And that's just, that's just an interesting thing to look at and experiment.
So you've released the load now.
And see that the rate of charge is slowed down a little bit, and it takes a little bit more to power.
It just went into resonance now.
Yeah, you can hear it. If I had an amp meter, which I do in the other room, to watch that, it would shift. You would see the amps go, just, it goes through about 2 or 3 shifts.
Right. We saw that on the previous filming with John. You could see that.
Yeah, with that larger motor over there.
Yeah.
So we have, you can do this with any brushless motor. And so what I like to do on this one is I put a little reflective tape here, and I use a tachometer to measure the RPM. And what I've done is have one that's unmodified and just run it, at the 12 volts, or this one's a 24 volt system. And, monitor the RPMs for the given amount of energy that it takes to run the fan. And then compare that to this fan that has been converted. And try and match at least the RPM for the power ratio. But then, at the same time, charge another battery. Or several batteries, which I've been able to do. Now, one thing to note about this, just like in the regular monopole motor, is that the wire inside gives you different kinds of results. This one is the exact identical fan that I got at Radio Shack. And this one is a thinner gauge wire, and it is actually more efficient than this one. But this one only gives me a certain amount of power. So that, if you want to have a really efficient system, you can go with a smaller gauge wire to a certain extent. But if you want to have more airflow here with this size of a fan, then you're going to have to go with some higher gauge wire. So we were just doing some experiments trying to match it in the way that I was talking about it, trying to get the RPM exactly the same as the unmodified motor for the same amount of wattage, which is 3.84 in this particular fan. So it just takes a little bit of time to figure out which gauge wire will work to do that kind of thing. And there is if you want more power on these fans, you can sacrifice some of the charging. That's what I've found. So I tend to be a guy, I used to be a mechanic, I like torque, I like power. So I tend to push them pretty hard. But it's not always the best kind of charging, unless I load it down like this. And then you can see it's starting to go up. So we have several of these as kits. I've got a 10-inch fan that's a little larger than this 6-inch fan, and it all does the same thing.
And so you sell these for experimenters to...
Yeah, what happened was we have a little kit that is just a basic monopole, as we just saw in the film, where, there's a coil and a basic circuit and instructions on how to put it together. But people were complaining, well, I don't want to make a big wheel, and I don't have the... So we thought about putting together a little kit that had all the parts in it, and it was, professionally machined, and it gave a direct comparison to the motor, so you knew exactly the difference. Because people were saying, well, there's no real mechanical power in this. Oh, I mean, it's not really meant as a motor. It's more as a mechanical oscillator, as in the patent. But there still was that, as John said, 23% mechanical power there, which needs to be appreciated. So I've made about 140 different monopole SSG schoolgirl setups over the last 3 years, and just experimented with different kinds of arrangements. And so this is just one of the latest ones that we've done.
And then run this one.
Yeah, I was going to do that.
The battery guy understood.
Yeah,
One battery guy understood
Kevin, yeah.
that you just can't charge batteries that way. So whatever's here is totally different.
Right.
And the thing that we're actually trying to get across to, we're trying to make this as simple as possible for people. It has to be as simple as possible for people because they really don't understand what the energy is. And they're not willing to take the time to go and research for years and years and years to figure out, well, hey, what these guys are terming free energy is the mechanical energy. It's the mechanical energy they're getting for free. They've never had anything that they could run as a toy, and you can consider this a toy. They've never had anything that you could take and get this mechanical energy out of it, or wind, to cool yourself off. And it would be very easy to drip water by this, and you have an air conditioning unit that recharges its own batteries.
Yeah.
But they're not willing to take the time to understand that. The future is about efficiency. It's about understanding what these forms of energy are. As we demonstrated earlier, that negative energy is one thing and charges a battery totally different than what positive energy charges the battery. So, we have to understand the forms of energy, and what everybody's terming as free energy is just a change in the energy. Tesla wasn't going to do anything mystical here.
And I would imagine the government isn't going to want general information known either. They'd want to, proprietize it in some way. If that's a word.
The government has not indoctrinated the people into being efficient about anything. Mm-hmm. It's all politics. It's all what can we hide, what can we take away, how much can we control these people, what kind of a slave do you have to be to run this government?
Yeah.
It's very simple. You go to work, you give them 60% of your paycheck, even more. Because when you go to the store for food, you're paying taxes on the food, you're paying taxes here, you're paying taxes there. Pretty soon, you know what you're left? You're left with about 2% of your income. You start raising the fuel costs, and you create a debtor nation. You create a society of slaves. They don't have anything. They're not going to do very good work. They haven't figured that out yet. Okay, you're going to get half-assed work, and that's just plain and simple. That's what you're going to get. You're not going to get anybody that's worth a crap. And the reason that there is not an efficient motor out there that draws its energy from the ambient surrounding is because you have people that are feckless.
Right.
Okay, we've sort of broken through, and we've touched the first and second phase of this operation. Tony spent a good deal of time filming people that supposedly, mysteriously make this witchcraft work. So to a normal engineer, this is witchcraft. Mm-hmm. This is something he wouldn't do. It's not in his textbook.